Hello everyone, my name is Arya Devdhar and this is part 2 of NCERT Class 10 Science, Chapter 1 Chemical Reactions and Equations. Okay, so in part 1, we saw the representation of elements using symbols. So we saw the first 20 elements and some others which were not included, but they are also still very important. After that, we saw what exactly is a chemical reaction and how can you identify whether a chemical reaction has taken place or not. Okay, so in this part, we are going to see a new topic which is called chemical equation. Okay, a chemical equation. So, what exactly are chemical equations? We are going to see that. Then we are going to see how can we write a chemical equation. So, subpart. How can we write a chemical? So, writing a chemical equation basically, there are some factors which sum up to give you a chemical equation. So, we are going to see each and every one of those factors. Okay, so writing, and then we are going to see a very important part, which is how to balance a chemical equation. So, balancing of chemical equations. We are going to see why we balance them and how can we balance them. So, the easiest way possible. Okay, so let's start. So, what is a chemical equation? A chemical equation is nothing but a representation. It is a representation of a chemical reaction. Okay, so a chemical equation is nothing but a representation of a chemical reaction. Okay, so this is very easy to understand. It's sort of a shortcut way of writing a chemical reaction. You cannot write it every time in word form. So this reacts with this to give this and releases this gas and stuff like that. You cannot write it every single time. That is why chemical equations have been formed to ease our lives. So it can also be said as a shortcut to represent a chemical equation. Shortcut, a chemical reaction. Okay, it's basically a shortcut. Layman language, it is a shortcut. Okay, now let's just take an example here. So for example, I take a very simple equation, which is carbon plus oxygen gives carbon dioxide gas or carbon dioxide. A very simple example. Now here, as I have written it in the word form, so I've written carbon plus oxygen gives carbon dioxide. So this type of equation is known as a word equation. Okay, it's known as a word equation. Now we can convert this to a proper chemical equation. How? We have to substitute the symbols of these elements and compounds. So that is C plus O2 gives CO2. This is the chemical equation of the word equation given above. So chemical equation. Easy enough to understand? Okay. Yeah. So now moving on. Now we'll see how can we write a chemical equation. As I said, there are some factors which come under writing a chemical equation. So let's start with the first one. The first factor is adding physical states. So basically what I'm talking about is we write the physical states of each and every element or each and every compound given in the chemical equation. Why do we do this? Because it provides us more information about that reaction. Okay, so for example, there is, I'll take the same example which is given above. Okay, so it is C plus O2 gives CO2. Okay, so for example, if you want to conduct this experiment in the lab and you don't know, like it's only given this much, okay, that's all which is given. So you don't know in what state should you take carbon, in what state should you take oxygen, so that you will get carbon dioxide gas, right? So you have no additional information, and maybe the chances of the experiment going wrong are quite more, right? So that is the reason why physical states or extra information is given when writing a chemical equation. Okay. Now, the physical states are, there are five. So there are the normal three: solid, liquid, and gas. And then there are two more, which are aqueous and precipitate. So these five states are there. Now, solid, liquid, gas you are familiar with. Aqueous means dissolved in water. Aqueous means dissolved in water. This state has been, recognized because most of the reactions, they do not take place in the solid state. They have to be dissolved in water, or they have to be in the aqueous state to take, to react. So hence aqueous state was recognized. And then precipitate, in which I have already told you about last lecture. Precipitate is basically a solid product which is obtained. Okay, solid and precipitate are the same thing, but precipitate is, it is a very important type of solid which is formed, solid product. So it has a solid product obtained. Okay. So these five are the physical states. Now, for example, here is one of the examples. So C plus O2 gives CO2. Here, carbon is in its solid state, oxygen is in its gas state, and carbon dioxide is also obtained in its gas state. Okay, pretty easy to understand this one. Let's see one more example. So, for example, we have Mg plus O2 gives MgO, right? So here Mg is in its solid state, O2 is in its gaseous state, and MgO is in again in its solid state. Okay, because it is obtained as a white powder. So MgO, magnesium oxide, is obtained as a white powder. It is obtained along with the release of heat and light. Okay. So I hope you understand adding a physical state. Now let's go on to the second part, which is adding extra information, which is basically adding physical conditions. Okay. So adding physical conditions. So what is this physical conditions? So for example, each of the chemical reactions, they require specific temperatures, or they require specific pressure conditions to react, right? So there are certain physical conditions that must be applied. For example, there may be a catalyst, there may be heat, or maybe electricity, or the sunlight, something like that is required to make sure that the reaction goes on smoothly. So we need to make sure that the chemical equation tells us about such physical conditions. That is why we add some symbols or something in the chemical equation to inform us better. So I'll take some examples here. Okay, so the first example is CaCO3. Okay, CaCO3 decomposes under heat to give CaO plus CO2. Okay, now here CaCO3 is solid, this is solid, and CO2 is gas, so this is gas. Okay, now here the physical condition is this delta sign, which is heat. Okay, so heat is required for this reaction to take place. Simple enough to understand. Okay, so in some cases it requires sunlight, in some cases it requires electricity, it depends. Okay, in some cases it also requires a catalyst like acidified potassium permanganate, or K2Cr2O7 like potassium dichromate, etc. Okay, so that will come up when we see such reactions. For now, the heat example is good enough. Now, moving on to a very, very important addition or factor for writing a chemical equation, which is balancing. Okay, sorry, which is balancing. Now, balancing, we are going to see down here, because it is so important that we have to spend some time on it. Okay, so why is balancing necessary and what does it mean? Okay, balancing basically means that, for example, there is a I'll take an example of Mg plus O2. Okay, so Mg plus O2 gives 2 MgO. Okay, MgO. So this is a skeletal or unbalanced equation. Now here you can see that there is one Mg atom here. There is one Mg atom here. Now there are two oxygen atoms here, but there is only one oxygen atom here. So where did one oxygen atom go? Did it go into the air? No, it did not. So it's still in the reaction, right? So where did it go? We have to explain this, and that is the reason why balancing is quite necessary. Okay. Another reason, so basically this was in layman terms. The scientific reason for balancing chemical equation is to follow the law of conservation of mass. Okay, it is to, I'll write it down. It is to follow the law of conservation of mass. So now what does this law state? It states that matter can neither be created nor destroyed. It can only be transferred from one form to another. Okay. So here in this equation, which is unbalanced, one oxygen atom has been destroyed. It is appearing that it has been destroyed. But that's not true, is it? Because it cannot be destroyed. So we have to show that two oxygen atoms are on the LHS and two oxygen atoms are also on the RHS. Okay. So to follow the law of conservation of mass, which states that matter can neither be created nor destroyed, it can only be transferred from one form to another. Balancing is very essential. Okay. Now how to do it? It's again a very simple process. Okay. So write LHS, write RHS. Now write down whichever atoms or whichever elements you see here. So I see Mg and O, and RHS also Mg and O. So your elements on LHS should match those of RHS. Okay, simple. Now how many atoms are there? Check. So there is 1 and 2. Here there is 1 and 1. So I'm sorry. So clearly oxygen is not balanced. So to balance oxygen, you have to put a 2 before the entire compound. So that means twice of MgO. That means 2 of Mg and 2 of O. So here O becomes 2, but Mg also becomes 2. Understanding? Okay. And now magnesium has 2 atoms on the RHS and only 1 on the LHS. So we need to add a 2 here. So we have 2. So magnesium 2. So magnesium 2. Magnesium 2. Oxygen 2. Oxygen 2. So this equation is balanced. Okay? And finally, after doing all this, how do you write it properly in your board exams? So after balancing it, finally you write 2 Mg plus O2 gives 2 MgO. Okay, you have to box the coefficients. These are called coefficients, which are before the element or the compound. Okay, so those are called coefficients. You have to box them in order to let the checker know that you have balanced it and you have got these coefficients. He will only check the coefficients. If they are right, he'll give it right. Okay, and make sure you don't forget to write this too as well. Don't box it because it is there from the beginning. It was there in the original reaction. It is there in the balanced reaction. So don't do anything to it, but don't remove it as well. Okay. So this is how you balance a reaction or a chemical equation. So these are the three things which are very essential when you write a chemical equation. Now in the next part, we will be discussing a few more examples for balancing chemical equations. So that's it for now. Thank you so much.